Hi everyone, welcome to yet another webinar in the MI2 series, and this time it's all about Knative. So my name is Janakiram MSV and I'm going to be the presenter. I'm a Google developer expert on cloud and IoT, as well as a Google Cloud certified professional cloud architect. I'm pretty excited to bring you this session, but before we get started, I want to set the context on what is MI2. So MI2 is a series of webinars that focus on the convergence of machine intelligence and modern infrastructure. Machine intelligence is all about IoT, edge computing, cognitive computing, AI, and deep learning. Modern infrastructure is all about Kubernetes, service mesh, Prometheus, Istio, and related technologies. It's all about microservices. Every alternate week, I switch between these two tracks, primarily on the infrastructure and intelligence track. And every webinar is complemented by a tutorial, code snippets, and a video. So if you are watching this on YouTube, click on the description and you'll find a link to the article, the concept, and even a GitHub repo if applicable. This is a completely independent and neutral platform to explore emerging technologies. This is not a marketing platform or a sales page or a promotional activity for a specific vendor. So having said that, I want to launch a quick poll to make sure that you are able to see my screen and listen to the audio. So this poll would help me understand if you're able to follow this session. Excellent. Looks like the AV experience is good. So I'm going to close the poll and get started with the session. So Knative is a pretty interesting technology. So like most of my sessions, this is going to be a very demo-centric, demo-driven session. But before that, I want to set some context by doing a quick recap of what is serverless computing, followed by a discussion around what is Knative, and then we'll take a closer look at the components of Knative. So even if you're not very familiar with serverless computing or Knative, this would still help you understand the big picture. And stay tuned for the demos. I have 3 demos where I'll show you everything that you need to understand about Knative. So serverless computing is becoming a parallel trend to containers. Today we have 4 different computing stages. The first one was bare metal or physical servers. The second generation or the second wave was all about virtualization and VMs, driven by VMware, Microsoft, Citrix, and others. The third wave of computing is containers. That's what we are experiencing today. And the fourth wave of computing is all about serverless. Today, we actually experience both. We are building microservices that take advantage of both containers as well as serverless computing. So this is clearly the new trend where we write traditional applications as microservices and event-driven applications as functions that run in the serverless environment. So what really qualifies to be a serverless computing environment, and what exactly is serverless computing? Well, there is a lot of confusion on what is serverless computing, and a lot of vendors, a lot of cloud providers are positioning many services as serverless related services and serverless computing based services. But how do you really apply filters? How do you qualify a service to be called as a serverless computing environment? The first one is you never have to provision infrastructure or configure infrastructure. If you are expected to launch VMs, install software, or configure anything before you run your code, then it is definitely not serverless. The second rule is basically on-demand execution. In serverless, you don't have long-running processes or long-running services. They come and go based on the request and response pattern. For example, the code that you deploy in a serverless computing platform will not be running all the time. Only when there is a request, it wakes up, it serves the request and dies again. So this is very efficient and it doesn't consume resources if it is not executing. So this on-demand execution is another criterion to qualify a service to be a serverless computing related service. The third one is auto scaling. With serverless, you don't really need to define rules. Like, if you are familiar with Azure VM scale sets or launch configuration and auto scaling groups in EC2, or instance groups and managed instance groups in GCE, you know that auto scaling involves a lot of configuration. You need to define min and max, you need to define the threshold, you need to define the cooling period, and a lot of configuration. For serverless computing, you don't need to do any of that. It basically shrinks and expands dynamically without you ever configuring a rule or a policy or defining a threshold. Of course, it is possible, but out of the box, auto scaling is supported by mature serverless platforms. And finally, serverless platforms charge you per second. They don't charge you on an hourly basis or not even minute. You're only charged for the number of seconds that your code gets executed. So these are the 4 thumb rules that you need to look for when you're dealing with serverless computing. No infrastructure to deal with, on-demand execution, which is also called event-driven execution because an external event would trigger your code towards execution, auto scaling, and per second billing. So those are the 4 high-level points to remember when you are evaluating serverless computing choices. So today we are actually looking at 2 different trends. On one side, you have CaaS. CaaS is containers as a service. Today you have Google Kubernetes engine, Azure Kubernetes service, Amazon Elastic Kubernetes service, IBM container service or IBM Kubernetes service, and all of them are managed Kubernetes services. And they are actually called as CaaS because they offer container orchestration as a service. So you write code, you then package it as a container image, and then you club multiple containers into a pod, and you deploy the pod on a Kubernetes cluster, and then the cluster takes over the orchestration and manages the entire life cycle of your workload, which is a collection of pods, deployment, services, replication controls, and whatnot. So that is one side of infrastructure. The other side of infrastructure is what we are seeing in the form of AWS Lambda, Google Cloud Functions, Azure Functions, IBM Cloud Functions, Oracle Cloud Functions, and a variety of environments based on serverless computing paradigm where you can execute code. And they are basically FaaS, functions as a service. And I'm actually seeing a lot of customers take advantage of both of these trends. So when you're writing an application as a cloud native application, as a modern contemporary microservices application, you don't target only serverless or you don't only target CaaS. You actually build an application that takes advantage of both the paradigms of CaaS and FaaS. But the problem is the entire CI/CD pipeline, the deployment paradigm, the way you think, the way you code, the way you deploy, the way you manage, the way you scale, the entire lifecycle management is extremely different between CaaS and FaaS. They don't talk to each other. They're not running the same code base. You cannot switch between these two easily, and you need to run 2 different silos. With so much of emphasis on containers, why can't we run serverless on Kubernetes? And that is exactly what Knative is. So Knative brings the power of serverless computing to existing Kubernetes clusters so that you can enjoy all the capabilities of serverless without really moving away from CaaS. So Knative is an open source project from Google, the key contributor, Red Hat, IBM, Pivotal, and SAP. Those are the key contributors of this open source project called Knative. So Knative is essentially a set of middleware components that run on top of Kubernetes. And the goal of Knative is to bring serverless computing to containers as well as existing Kubernetes clusters. Now, when you are using Knative, you don't need to deal with 2 different silos, 2 different runtimes, 2 different environments. One is CaaS, one is FaaS. Now, Knative brings these 2 together into one unified, consistent stack. The advantage that you get is, irrespective of whether your code is running as a Kubernetes workload or as a function in a serverless environment, you always package it as a container. So container becomes the universal deployment artifact or the unit of deployment, and you can decide what is going to run as an auto scale serverless workload and what can run as a traditional long running process on top of Kubernetes. So the other big advantage of Knative is it also brings the power of serverless computing to data centers. Today, if you look at functions as a service, which is a delivery model for serverless computing, it's predominantly available in the public cloud, whether it is Lambda or Google Cloud Functions or Azure Functions or IBM Cloud Functions. All of them are delivered in the public cloud, and they are managed by hyperscale providers like IBM, Google, Microsoft, and Amazon. Now, if you have a data center and if you're running modern infrastructure stack, how do you get the benefit of serverless? How do you get Lambda-like environment in your own data center? Well, it's not easy. Of course, there are some implementations like OpenWhisk from IBM, which is an Apache project, and there are a few other options, but they're not very Kubernetes native. The first project to bring the power of containers and serverless together is Knative. And customers can deploy this on data centers, that is on-prem. In multi-cloud environments, you can actually run Knative in any managed Kubernetes service that you're running, whether it is GKE or AKS or EKS, it doesn't matter. You can run Knative on top of any Kubernetes cluster, and you can get advantage of serverless computing. Of course, you can do it in hybrid environments where you have environments like Anthos or VMware's Project Pacific and Tanzu and Red Hat OpenShift. You can actually deploy Knative in any of these environments where you are running clusters across your private and public clouds, and of course, multi-cloud environments. And Knative encourages best practices of designing and deploying cloud native and serverless applications. So the key takeaway from this slide is Knative is an open source project from Google and other industry players to bring the capabilities of serverless to Kubernetes cluster. So that is what is Knative. Pretty straightforward. Now, Knative architecture, right? There is nothing fancy or complicated architecture or concept about Knative. It is basically built on top of Kubernetes. So there is Kubernetes, which is the infrastructure layer. Then there is Istio. Now I have done a bunch of sessions on Istio. You can find them on my YouTube channel. You can read about Istio in my news stack articles, and I've covered this extensively in my sessions and articles. So Istio is essentially a service mesh that is sitting on top of Kubernetes, brings in routing, blue-green deployments, canaries, security, telemetry, a lot of production grade capabilities for microservice deployments. So Istio has become the indispensable layer for running production workloads on Kubernetes. So you have Kubernetes that is providing core infrastructure. Then you have Istio that is providing network, security, and telemetry capabilities. And on top of Istio, we have Knative. And Knative essentially has two components, two pillars. One is called Knative Serving, the other one is called Eventing. Now, these two deliver the capabilities that we have been discussing so far. Now, Istio is a very mature, popular service mesh. But the good thing about Knative is it can actually run with a couple of other implementations of service mesh. You don't need to use Istio per se. You can actually run Glue, which is another API gateway and a semi-service mesh-like layer coming from solo.io. And there are other service mesh implementations that may be eventually supported, but Istio is the most preferred layer to run Knative, particularly if you are using GKE, that is Google Kubernetes Engine. There is a managed Istio service with a checkbox. You can actually get Istio up and running on your GKE cluster. So that makes it easy for you to install Knative. And Knative takes advantage of multiple Istio capabilities. So it is fair to say that Knative has a level of dependency on Istio. So this is how Knative is layered. Now, Knative is nothing but a workload on top of Kubernetes. After you install Knative, and if you check out what has actually been deployed, it is not very different from any other workload on Kubernetes. You'll see a bunch of CRDs. Now, CRD is a custom resource definition, which will bring additional capabilities to typical Kubernetes objects. Now, we are familiar with pods, deployments, services, secrets, config maps. Now, all of them are actually resources in the context of Kubernetes. Now, Knative actually extends that by installing a service. Now, a service is not really a Kubernetes service. It's a microservice, which is encapsulating both a deployment as well as a service and everything that you need to go live. So Knative comes with a bunch of CRDs, and these CRDs are abstracting the underlying capabilities of Kubernetes so that developers can focus on creating a service rather than dealing with a bunch of YAML files that represent a pod, a deployment, a service, a config map, a secret, a persistent volume claim, all of that. You don't need to deal with any of that if you're targeting Knative, because you can define a service, and when you throw it at Knative, it will negotiate with Kubernetes to do everything required to basically expose your microservice. So that is how Knative is layered and structured on top of Kubernetes. Now let's take a closer look at the serving and eventing components. So Knative serving is actually like a PaaS. Now, if you remember platform as a service, I have been working on cloud for exactly a decade, slightly over a decade. My first encounter with cloud actually took place in 2008. And the very first service that I used was Google App Engine. And Google App Engine back then and even now supports one key capability, that is bring your source code and walk away with a URL. And then we had services like Azure PaaS, Cloud Foundry. Then we had EngineYard, the Heroku. So there were like a lot of platform as a service implementations. And the promise of PaaS has always been that bring your source code and we'll give you a URL. You don't need to deal with anything to do with provisioning, configuration, scaling, security, all of that. You point us to your GitHub repo, and every time you commit, we will do the entire CI/CD for you, and you get a URL. If you want, you can generate a new URL and wire it up to your DNS, or you can overwrite your existing deployment to the same URL so that new version shows up to your users. So the promise of PaaS is always bring your code, go away with a URL. Now, Kubernetes is not a PaaS, but it is definitely a platform. In Kubernetes, it takes quite a bit of plumbing and additional work to walk away with a URL. You cannot really bring source code to Kubernetes and walk away with a URL. Of course, that is possible if you're using OpenShift, but OpenShift is actually a PaaS built on top of Kubernetes. But Knative serving attempts to bring PaaS-like abilities to Kubernetes, so that developers don't need to deal with spaghetti YAML files that represent half a dozen artifacts. So you bring your source code, or you bring a container image and walk away with a URL. Very simple. And what happens in between, you don't need to worry about. And how about scaling? When does my service scale? When does it get terminated? You don't need to really manage that. So Knative serving is bringing PaaS-like capabilities to Kubernetes. And there are 4 components of Knative serving. The first one is a service. A service is essentially a microservice. This represents a Docker container image with a tag. It also represents the port on which your service is expected to run. Now, routing is closely tied to the service mesh. So routing will help you define custom policies on how your application is going to respond. For example, you may have V1 and V2, and you want to route traffic selectively to V1 and V2, or you want to do a canary deployment. You can do all of that with routing. So routing reflects a lot of Istio capabilities or service mesh capabilities through Knative serving. So that will help you selectively route traffic to your backend microservices. Configuration is basically everything that is outside of code. Things like environment variables, things like configuration settings, things like ports, a lot of settings that are external to your microservice go into configuration. And every time you make a change to the service or configuration, you end up getting what is called as a revision. So a revision is a point in time snapshot of both code and configuration. So every time you modify the service, that is committing code, creating a new container image and pushing it, or you make a modification to configuration, Knative serving will essentially generate a new revision. And these revisions will represent different flavors, different versions of your application. These versions could differ from the code base, or they could differ based on the configuration. Now, when you have more than one revision, which is reflecting some kind of a change in the code or configuration, you can take advantage of routing to selectively send the traffic to one of the revisions. So if you actually look at Knative serving, it is like Google App Engine, it is like Cloud Foundry, it is like Heroku or IngeneYard or Dice, any of those, because you basically deal with a deployment unit, which is a container image. Now, Knative can also work with pure source code. Of course, you need to bridge the gap. For example, the previous version, the previous incarnation of Knative also had a component called build, but it has been deprecated and removed in favor of some of the tools from Google, like Tecton, and some of the other tools. There is Tecton, and there is one more tool that is actually very popular for building source code within the Kubernetes context. So what that component or that step does is to basically take your source code and then within Kubernetes build a container image, push it to a container registry, and then send it to Knative serving. But that has been kept outside of Knative, so you can actually use Jenkins, you can use Spinnaker, you can use any of your existing CI/CD tools to basically package your code and ultimately land your container image in Knative serving. So Knative serving is like a PaaS, and one of the key capabilities of Knative serving is scale to zero. Now this is very unique. When you actually run code, PaaS, or for that matter autoscale, can never go beyond 1, right? So beyond 1 as in to 0. You cannot have an application become 0 instances when there is no request and automatically wake up when there is a request. This is possible with Lambda, but not with Kubernetes, not with Docker, not with any other infrastructure. That's the capability Knative serving brings. So if you deploy a service in Knative serving, and if you are not sending any traffic to it, it will die. But it doesn't mean it has died permanently. It basically dies till it receives a new request. And the moment there is a request, Knative serving will figure out that there is a request and the pod is not available. It automatically wakes up your application, and there is a little bit of latency for the very first time, that is called the cold start, but subsequent requests will automatically go to the existing pod. And when Knative serving realizes that the existing pod is not able to scale, it automatically spins up another pod, and that's how it basically replicates. And again, when the traffic subsides and when it comes down to baseline or even no traffic, then all the instances of your application will automatically die. So that is the beauty of Knative serving, which is called scale to zero and scale to n. Now, the next component of Knative is very exciting, very interesting, and this is what is actually bringing us the event-driven execution, and that is Knative eventing. So Knative eventing is a loosely coupled event infrastructure for cloud-native applications. Now, all of us are familiar with PubSub, right? So you have a publisher and you have a subscriber. Subscriber subscribes to a topic, and the topic is handled by a centralized broker like RabbitMQ or MQTT or NATS or any MSMQ, or in Azure context it is Service Bus. Basically, you have a centralized broker, then you have a set of publishers, then you have a set of subscribers. Now, because we have a middleman connecting subscribers to publishers, they don't need to talk to each other directly. So that is the PubSub model, and it has been proven. There are a lot of implementations, and today most of the distributed systems take advantage of this PubSub model. Now, the Knative eventing concept brings that kind of a PubSub capability to Knative eventing. So you actually see a small typo here. It is Knative eventing. So, oops. Okay. So Knative eventing, as I mentioned, is the PubSub runtime within Kubernetes cluster. So there are 4 pillars. The first one is a source, right? It is a producer that reads the event from actual source. Now, the source is like a proxy for the original publisher, right? For example, you may have Google Cloud PubSub or RabbitMQ or Apache Kafka. Now you need to have someone within the Kubernetes cluster listening to messages that are coming through these message buses. So that is the source. The source is a proxy for the producer because it reads the events that are coming from the actual source. And then the source basically sends the messages to the broker, and the broker is the middleman. It is actually saving the messages and then it fans out to all the subscribers. So a subscriber in the context of Knative eventing is nothing but a microservice. It's a Knative service. It is not very different. Any pod, actually not a pod, in the context of Knative, it's always a service. So service is like a microservice. Don't get confused between Kubernetes service and Knative service. So let's call this as a K service. So a K service is just like a microservice. It doesn't have any idea about whether it is consuming messages coming from the broker or is it responding to HTTP. It doesn't matter. So you write a service and you deploy it. But what will bind the K service with the broker? That is, how does the broker know that this service is actually interested in receiving messages sent to a specific topic, or messages coming with a specific regex expression? That's where we have the trigger. So the trigger binds the broker with one or more services that act as a consumer. So source is a proxy of the original event source. Its job is to grab the message and dump it at the broker. Broker will ask trigger, hey, who is interested in this message? And trigger will say, okay, service 1, service 2, and service 3 are interested, and broker will automatically push those messages to those services. So that is the job of a trigger. So trigger will actually trigger the code inside your service when the broker has a message that matches the specific criteria or the channel information that the service is interested in. So again, if you are familiar with RabbitMQ, if you're familiar with Google Cloud PubSub or Azure Service Bus messages and message queue, it's not very different. The only thing is it's all running in the context of Kubernetes. So I want to also touch upon Cloudrun. Cloudrun is a commercial implementation of Knative from Google. It's one of the very first commercial implementations to go live in the public cloud. Of course, it is still in beta, but nevertheless, it's one of the very early and also the best implementations of Knative. And if you are interested in understanding more about Cloudrun, a month ago, I did a session. There are a lot of demos and there are a lot of tutorials that I published. So take a look at those tutorials and this session to get a good understanding of Cloudrun. But Cloudrun is like a commercial implementation of Knative. So what Google has done is it has taken Kubernetes as the infrastructure, that is GKE, Knative as the platform, which is PaaS, and then the developer tooling experience, and the developer experience is delivered through Cloudrun. Does this mean other providers will follow the suit? Absolutely. For example, IBM is betting big on Knative. So IBM might create a Cloudrun equivalent that will simplify deploying services and event publishing to Knative. So it may have its own experience and its own developer layer, or developer experience layer, front-ending Knative. Red Hat is already doing that with the most recent version of OpenShift, which is 4.0. It has developer tools that integrate very well with Knative. Now SAP will do the same, and Pivotal will do the same, Pivotal and VMware. So we'll see a lot of implementations of Knative that will simplify the interaction with developers. That's the reason why I brought up Cloudrun. So Cloudrun is a commercial implementation of Knative, available as a service, as a managed service on top of GKE or as a standalone service. Now I want to jump into the demo and walk you through everything that you need to understand about Knative. So I have 4 demos actually. The first demo, I'm going to walk you through the setup process. I'm not going to do the setup. It's going to take a while, so I'm going to walk through the steps, and I already have the fully configured environment ready, but I'll walk you through what it takes to set up Knative in GKE. That is my first demo. My second demo is deploying a service with Knative serving and seeing scale to zero in action. The third demo, I'm going to show you basic Knative eventing with a cron job. So we'll run cron job as a publisher, and cron job will publish a hello world message every 1 minute to the broker, and the service will pick it up from the broker through the trigger. So that is my third demo. My fourth demo is pretty interesting. We'll actually integrate Knative eventing with Google Cloud PubSub, and every time I publish a message to Google Cloud PubSub, one of the microservices in my cluster, in my Kubernetes cluster, will end up receiving that message. So it's going to be pretty interesting. Now let me jump into the demo and walk you through how all these actually line up. So I'm going to switch to my command line and then show you what it takes to set up Knative. So here is some script, and I'm going to publish this as a part of my new stack tutorial, so stay tuned for that. Now, if you are familiar with GKE, you notice I'm actually setting up my GKE cluster name and then the cluster zone. I'm launching this in Asia South 1A, which is Mumbai. And then I need to enable some services like cloud APIs, container registry. So this will make sure that the services are really available and I can talk to them via the CLI and the portal. And then I go ahead and provision my GKE cluster. And everything is standard, except that I'm actually using an add-on called Istio. This is critical. You cannot really install Knative on GKE without having Istio baked into the cluster. So we will actually enable Istio as the add-on. If you're launching this from the portal, it's just a checkbox. Now, once we deploy the Kubernetes cluster, then we'll actually add the current user make the current user as the cluster admin so that he can deploy anything in the cluster. So that is the command that you see here. We are creating a cluster role binding by adding the current user to this role called cluster admin. After that, we will download Istio, the latest version of Istio, and install what is called as local gateway. This step is completely optional, and let me spend a minute explaining you why it may be required. Now, by default, when you're using Knative serving and when you deploy code, everything shows up on the ingress. That is, it's a public facing endpoint. But what if you have a internal only service that you don't want to expose to the outside world, but treat it like an internal service? You need to create what is called as a local gateway and then mark the service to run within the local gateway so that that service remains internal to your cluster and doesn't show up on the ingress. So that is what is required, and this pretty long command that you see here generates the local Istio gateway. We'll apply that so that some of the services can run obscured within the Kubernetes cluster and they are not shown in the public domain. So after that, we will actually do a dry run by running the kubectl apply, and after that we basically deploy the actual components like serving, eventing, and so on. So all of that will get deployed, and then Knative will become the topmost layer of your stack. So if you look at the kubectl apply command, we are basically pulling the serving YAML from GitHub, the eventing YAML, and also the monitoring one, because when you install Knative, you get Elk stack, you get Prometheus, and a lot of those metrics related services, because Knative uses those metrics to decide when to scale and monitor the overall health of the service and so on. So that's where we are also deploying monitoring.yaml. But these three will get the most essential components and the key pillars of Knative. Now I have done all of this. So let me switch to the command prompt and show you what I have here. So first command is kubectl get nodes. You notice that I have mi2 Knative as the cluster name, and I have 3 nodes deployed 2 days ago. Then if you look at the namespaces, you actually see that there is a Knative eventing, Knative serving, and Knative monitoring namespace. This is where the CRDs run, the custom resource definitions. I also installed the Google add-on for integrating Google services with Knative eventing. So that's why you actually see that Cloudrun events is also available. Then if you actually do a kubectl get CRDs, there are a ton of CRDs that are installed as a part of Istio as well as Knative. So if you actually look at the CRDs ending with knative.dev, they are basically responsible for all things Knative. And for example, here, if you look at serverless services, networking, internal knative.dev, this is very important. It's one of the services responsible for implementing the scale to zero and some of the routing policies of Knative serving components. There is routes.serving.knative.dev. There is revisions. So you see that all the core components of Knative are deployed as CRDs. Now, this is a confirmation that Knative is up and running. So now I will deploy the very first service. So I want to take a very simple service. Now I don't want to overwhelm you with complex demos. If you really want a complex demo, you can take a look at my MongoDB plus Node.js application and deploy it on Knative. But I want to keep this simple, so I'm going to deploy a simple Hello World app. So the first demo deals with Knative serving, and for that we are going to deploy a Knative service. Now if you actually look at this, API version is serving.knative.dev. Now this is one of the CRDs. You can actually do a grep and you will find that. So when you do get CRDs followed by grep, you'll see that these are the exact CRDs that I showed you in my slide. So if we go back to Knative serving, service routing, configuration, and revision, you see all of them here. And this services.serving.knative.dev is what we are referring in our code. Now, this is a kind service, but again, this is not a Kubernetes service. This is not a cluster IP. This is not a node port. This is not a load balancer. It is a microservice. It's a service in the context of Knative. Now, don't get confused. So we are targeting the default namespace. The spec simply says, this is the image, and I'm using one of the Google samples. So it is coming from Google Container Registry, Hello World Go. It's basically a simple Hello World program written in Go and packaged as a container image. And it accepts one environment variable, target, and you can pass a name. I'm passing mi2 to that. So when you actually run this and when you execute code, when you hit this service, you'll actually see a hello world. So very straightforward. But the key thing to understand here is this is not a pod, this is not a deployment, this is not a Kubernetes service, this is not a replica set. It is a service, and a service encapsulates both the actual container image that is running your code and also the actual endpoint that you're going to get. And that endpoint is also defined as a part of this container. Now, by default, it is port 80, so you don't need to define that. Now, we take this service and simply deploy it in our environment. So let me switch to demo 1. And here, I just have the same service. So we'll go ahead and deploy service.yaml. Now, what we'll actually do here, I'm going to split my screen. And here, let's run this in watch mode. Kubectl get kservice. Now, kservice is a shortcut for Knative serving component, which is the Knative service. So we'll run this. And when we deploy, this basically results in Hello World Go. So this is the new service, and the URL is also published. Remember, I told you that the promise of PaaS is to publish code and walk away with URL. That's exactly what Knative serving is delivering us. We didn't package it as a pod or a deployment, then we didn't create a service, we didn't have labels, selectors, all of that, nothing. take your code, package it as a container, push it to Knative serving, and you get a URL. So this is the URL. But what can we do with this URL? Well, we can actually invoke. But how do we invoke? Well, this service is listening on a arbitrary URL called helloworldgo.default.example.com. We cannot really use this. Now, obviously, if I do a curl, it will fail. So if I do a curl, it cannot resolve. It doesn't exist. But what this actually means is this service is available as a service, as a Kubernetes ingress. So if you actually do kubectl get service in the kube system namespace, you'll actually in the Istio system namespace, you will see what is called as the Istio ingress. So Istio ingress gateway is the actual endpoint on which our service is published. And this is available on a load balancer with this IP address. Now, we can automate this process. This load balancer has nothing to do with Knative, to be honest. It is a load balancer that is representing the Istio ingress gateway. Because Knative serving integrates with Istio so well, so tightly, we grab this public IP address of the load balancer and do a HTTP get on that. So if you don't want to do this and do a copy paste manually, you can also run a couple of intelligent commands. So we'll set the ingress gateway variable to Istio ingress gateway, and then get the service. So this is the public IP address, external IP, and then we'll actually use the magic of kubectl to grab the IP address of the ingress gateway. So this is exactly the same IP address. Now what we'll actually do is a curl on the IP address, but we're going to send the header. We'll embed the header in the HTTP request so that the ingress knows how to route this to the appropriate endpoint. So now when we actually hit enter, this is going to take a while, and then it shows up hello mi2. And now let's do this. What happens if we actually do kubectl get pods? Well, behind the scenes, Knative serving has taken our microservice or the Knative service and turned that into a pod. And this pod, like any other Istio pod, has two containers, one sidecar and one hello world go container. So this is currently running, and it's been running for 30 seconds. Now let's wait for another 30 seconds. I want to show you scale to 0. Now the request has been sent, the service has responded, and now there are no more clients, no more connections to this service. So now the sidecar is watching if there are any active connections, and if there are no connections, it will tell Knative serving to destroy this pod. So in just a few seconds, I think in about another 30 seconds, there we go. Exactly after 1 minute, the pod gets terminated, and there will be no pod running after 1 minute because there hasn't been any service. This is scale to 0 in action. Now, you cannot really achieve this if you're not running Knative. If you're running a very heavyweight pod, for example, that's using JVM or traditional .NET, and you are really concerned about the resources consumed by this pod, you can actually use scale to 0. Now look at this, the pod is gone. Now what happens if we really come back and make a request? Well, thanks to Istio and Knative, this will result in the recreation of the pod, and the pod will show up again. Now there is a bit of a delay, and that is the cold start, because from container creation to running, there has been a delay of a few seconds, and that's what you see here. And subsequent requests will always be very fast because it is hitting the pod that's already warm, that is maybe hot. So that is scale to 0. Now I want to show you a few more things. So what happens if you deploy a Knative service on Kubernetes? Well, it results in multiple things. If we have already seen this. kubectl get service is actually a microservice responsible for code plus configuration. and it is showing us the URL. You can also get the routing information. So kubectl get route will show us that this is the URL which is responsible for actually routing the request. Now, if you have more than one version, you can create multiple routes, and you can also define the weight, and that is very similar to how Istio handles the traffic. You can also get the configuration. So kubectl get configuration will show us, everything. Of course, this is a very simple hello world pod. We don't have any configuration, but if you have production workloads, you need to keep configuration separate from code, and that's what will show up here. Finally, there is a revision, right? So this revision, currently we only have one generation and one revision. We haven't modified the code, we haven't modified the configuration. So this is basically just one revision. But again, you can see the service, you can see the route, configuration, and revision. Exactly what we have discussed here. These are the pillars of Knative serving. This also results in a deployment. So kubectl get deploy shows us that there is a deployment, but currently there are no pods running because scale to zero is in full swing. It has basically terminated the pod, and that's the reason why the deployment shows us 0 of 0 pods are ready. So you can also look at the scaling configuration. So what we'll actually do here is get the config map for config auto cluster, auto scaler. So config auto scaler is basically the config map that contains a lot of settings that is responsible for maintaining the auto scale of Knative serving. Now let's take a closer look at it. So what we'll actually do is we will we will actually define the we'll use describe to look at the scaling. Now if you let's actually set the editor as Sublime, and then we'll actually do a kubectl edit. There we go. Now this is the actual configuration, and if you look at the config map, this is what is influencing and dictating the auto scale process of Knative. Scale to zero, grace period 30 seconds. So that means after the request, if there is no subsequent request within 30 seconds, scale to zero will kick in, right? Inactive revision. Now enable scale to zero is equal to true. If you don't want to run this, you can turn this to false and modify the config map. Max scale up rate, and then some of these are very sensitive settings. So as you notice, this is a pretty comprehensive config map, and you can change a lot of defaults to control and influence how the auto scale works. What I want to show you here is, even though Knative is very simple to deal with, and it has out of the box capabilities, you can take control of it, and you can define it per service, or you can define it globally through the config map. So that is Knative serving. I hope you get a good idea. Basically, the idea is take the code, package it as a container, deploy it on Knative, get a URL. Straightforward. And then you enjoy the benefits of serverless computing, like per second execution, per second billing, on-demand execution, and auto scale. If you go back to my very first slide where I talked about how this all works, so no infrastructure. Of course, this depends on how the IT exposes. If you deploy Knative on an existing Kubernetes cluster, so Knative, the developer never have to deal with any infrastructure provisioning. On-demand execution, scale to zero, right? I mean, only when you hit, it actually wakes up. On-demand execution. Auto scaling, we have seen scale to zero and scale to n with multiple definable parameters and multiple configuration settings. Per second billing, Cloudrun doesn't charge you for every deployment. It only charges you for execution. So per second billing is also possible. That's exactly why Knative delivers the promise of serverless, because it meets all the 4 parameters, and criterion required to be qualified as a serverless computing environment. So let's now move to Knative eventing, right? So Knative eventing is pretty cool. It brings in the real event-driven model to Kubernetes. So let me switch to my next demo, and I'll show you some code, and then we will switch. So I have the first demo that I want to show you is we'll run a cron job, right? And a cron job would look like this. So cron job is also a part of Knative eventing. This is not a Kubernetes cron job. This is a Knative specific cron job. And if you notice, it's called cron job source. And this is actually what is available. For example, this can be container source, this can be Kafka source, this can be Cloud Pub Sub source. Cron job is the most easy one to visualize the capabilities of Knative eventing. So cron job source is supported within Knative eventing. So we are defining a cron job source, and then we are defining the schedule, which is basically every minute. So every minute, this cron job will print hello mi2 world to the sync, which is nothing but the subscriber. So here, we are not actually using a broker. We are directly bypassing the broker and creating a synchronous connection between the cron job as the publisher and the event display as the consumer. Now, event display, let's call it as a subscriber. So how does that look like? Well, this is not very different from the Hello World Go sample. It's a serving.knative.dev K service. We are calling this as event display, and it is coming from one of the images that are already available in GCR, the Google Container Registry. So this is acting as the subscriber. The cron job is acting as the publisher. And in this model, I'm not using a broker. We are making a synchronous matchmaking between the publisher and the subscriber. This is useful when you want to get everything instantly and when you have limited number of subscribers and only one publisher and you don't have multiple filters or rules and you want to keep it simple. So let's go ahead and run this sample. Now, first thing, let me actually delete everything that we have in the current namespace. So if you look at kubectl get all, now we have a bunch of stuff already running from the previous demo. So it'll have a deployment, it'll have a pod, a bunch of things, and all of them are currently running inside the default namespace. So let's actually get rid of them. And to get rid of them, all you got to do is kubectl delete -f service.yaml, and this will basically remove everything. Now, after a while, and when you do kubectl get all, everything will vanish. Because that one single thing, there we go, one single thing has deleted a whole set of Kubernetes objects and resources. So now, we don't have anything in the default namespace. We are back to the blank slate. And now, as a part of my demo 2, what I'll actually do is I'll first deploy the subscriber, which is nothing but an event display container, which will show us the logs. So I will deploy the subscriber. And subscriber is nothing but a K service, right? So here you notice that this is showing up as a URL, but we are not going to hit the URL. There is no web UI. And this is resulting in a pod, and it is running, right? Now, we are going to leave this as is, and then we are going to run the cron job as the publisher, as the source. So now we will run the cron job, and interestingly, cron job also results in the creation of a pod, because we are currently watching the pods in the default namespace, and this results in a cron job source, which is actually a pod. But at the same time, you can also look at get all, and you will see that the cron job is actually a source. So here, somewhere as a part of the Knative default event, so you'll actually notice that this is actually the object that we deployed. So if you do kubectl get cron job source, it shows there is one cron job. Now this is not, oh, the event display has vanished because it has just timed out and scale to 0 kicked in, and it has come up again because the cron job is sending some messages and this guy got to listen to it. Okay, so now cron job is running, and it is what we supplied. Now what we'll actually do is let's get rid of this, and now we will grab the name of the pod responsible for the event display. So if you actually run this, it will basically show us the name of the pod that is acting as the subscriber. So this is the pod name, right? So we grab that pod name, and then we'll actually do a kubectl logs on this pod. So kubectl logs will show us hello mi2 world, and this will be shown, this will be updated every minute, because as soon as the cron job will publish a new message, this guy will get updated. So this is really interesting and very powerful as well, because this is how you can create event driven applications within Kubernetes. Now you get an idea. In the interest of time, I'm going to move into my third demo, but before that, let me clean up my current namespace. I want to get rid of what we have here. All right, so now finally I want to show you a demo. I may not be able to walk you through all the details, but I'll show you the actual demo and you get an idea on how to really do that. So here we have a Google Cloud PubSub topic, right? So we have the topic name called testing, and Cloud PubSub topics create. So this is already there, so it's going to fail because I have created in the dry run. So this topic is already there, so you can actually do PubSub topics list, and it should show us the testing topic, right? And then I want to run the, let me make sure I have the Cloudrun. Okay, so the Cloudrun CRD is already in place. So now what I'm going to do is I'll actually run a source, right? A pull subscription. So this is going to be the proxy for Cloud PubSub. So this proxy will listen for any messages published to Cloud PubSub. So now we have created the source, and how does this look like? Well, here we define the actual topic name called testing, and look at this namespace, pubsub.cloud.run. This is coming from Google. It is not a standard Knative object. And then kind is pull subscription. So it basically pulls the messages that are coming to a specific topic. And then we are again, syncing this to the event display that we have seen in the previous demo. And event display is not very different. It is exactly the same. Now, I'm also going to launch my subscriber, right? And here we will run kubectl logs in watch mode. So when we actually run this is empty because there are no messages that are sent to Cloud PubSub topic. Now I'm going to use the gcloud CLI, and I'm going to send a message to the topic, to the PubSub topic. And as soon as I do that, we will see it here, right? That means the pod is responding to an event that is coming from an outside world. And in this case, we are actually publishing to Google Cloud PubSub. It is not even native to Kubernetes. That is the beauty. Unfortunately, this is slightly complicated. I don't have time to walk you through the setup process and the architecture behind, but I'm going to write a detailed tutorial in about a week or two on how to exactly do this. And I'll update the link in my YouTube video. So if you are interested in this scenario, watch out for the video and also look at the description. Now, this is another example of Knative eventing where we are wiring up a third-party source, and this could be Kafka. This could be any third-party source that can basically pipe the events into Kubernetes Knative eventing, and from there to any consumer that is basically a Knative service. So that concludes my demo. Let me clean up the resources. So I'm going to delete my pull subscription, which is the source. Now I'm going to delete the subscriber as well. So that concludes the demo. Now I want to thank our sponsors, Google Cloud. They are supporting me with a lot of credits and validation of the content and giving me early access. Newstack, my media partner, my long-term partner. I really like the work that I'm doing along with Newstack. Every tutorial, everything that you see here goes to Newstack. Foghorn, one of the edge computing companies in Bay Area, responsible for bringing multi-cloud industrial IoT and edge computing. Portworx, a container native, modern cloud native storage company, again based in Bay Area. They're doing phenomenal stuff in terms of bringing high performance multi-cloud storage capabilities to Kubernetes. I'm also pretty excited to announce the next session, implementing real-time edge intelligence in industrial IoT. The title might sound overwhelming, but this is going to be a pretty interesting session with live demos of two Raspberry Pis talking to each other via the edge and implementing real-time analytics and also running machine learning models at the edge. This is going to be co-delivered and presented with Foghorn, one of my partners. So we'll show you what is Foghorn Lightning and Edge ML. So do sign up at mi2.live. This is going to be on November 14th. So the daylight thing kicks in, and we have a 1.5 hour gap. If it is 8 a.m. PST, it is 9:30 p.m. in India. So do remember, if you're coming from PST time zone, it is changed starting, I think, November 4th. So so that is the next webinar. Now I want to quickly bring up a couple of polls. Did you like the session? How relevant was the webinar content? Brilliant. 87% of you say it is very relevant. Thank you so much for that. And I want to bring up one final poll before we wrap it up. How do you rate the overall quality of the webinar? This includes everything: my presentation, the content, the interaction, the quality of demos, everything. Great. Thank you so much. 70% of you say it is excellent, and remaining, they say it's very good. It's very encouraging. I'm committed to bring you high quality, cutting edge content every alternate week. My next session is on November 14th on edge computing based on Foghorn. Do sign up for that. And in a couple of weeks, I'm going to refresh the site and I'm going to move this into a new home. I'm pretty excited about that. You'll have an integrated experience of looking at all the past webinars and signing up for the upcoming webinars and a very smooth workflow. So I'm revamping the entire Mi2 experience. So do expect some changes to come in the future. I want to thank you for joining me. I hope you found this useful. If you have questions, reach out to me on Twitter. My coordinates are shown here. Unfortunately, I don't have enough time to take up the questions, but I'm always available to you on Twitter or social media. Do reach out to me, and I hope to see you in my next webinar. Thank you so much, and have a great rest of the week.